so secant is a reciprocal of cosine. So in quadrant 3, cosine is negative. The cosine of 30 is radical 3 over 2. So that means secant would be 2 radical 3 over 3. Number 2, 225 is in quadrant 3. Reference angle. Okay, in quadrant 3, secant is a reciprocal of cosine. Cosine is negative. Cosine of 45 is radical 2 over 2. So secant is a reciprocal, so we get negative radical 2. Sine of 30, that's just in quadrant 1, so it's positive. So sine of 30 degrees is 1/2. Okay, 330, that would be quadrant 4. Reference angle is quadrant 4. Cosine is positive, so sine would be negative. The sine of 30, 1/2. Okay, 120 is quadrant 2. Reference angle, 180 minus 120 is 60. In quadrant 2, sine is positive, so cotangent's negative. Tangent of 60 is radical 3, so cotangent would be radical 3 over 3. Okay, 210, quadrant 3. Reference angle 30, so in quadrant 3, tangent's positive, so sine is negative. Sine 30 is 1/2. Cotangent of 60, so tangent of 60 is radical 3, so cotangent is radical 3 over 3. 135 is quadrant 2. Reference angle 45. In quadrant 2, sine is positive, so cotangent's negative. Tangent of 45 is 1, so cotangent is also 1. 270. If you're trying to do the hand trick, it doesn't work as well. You could kind of treat it like a 90 and just think about positives and negatives. The other option is to think about x, y, and r. So you know that's a point 0, -1, and r is always 1. So cotangent is what? So 0 over -1 is 0. If you we're treating it like a 90, then tangent of 90 is undefined, so cotangent is 0. So we get the same thing. So 180, you could treat it kind of like a 0 and think about positives and negatives, or you could draw yourself a picture, x, y, and r. So if cotangent is x over y, -1 over 0, all right, how did we do? Good. Good. So this doesn't go away. We had them on the last test, we'll have them on the next test. We need to keep learning these values. Second thing I want to refresh for today is that unit circle. So we filled in a circle Friday, and we will continue to see this circle. We'll probably have one as a quiz eventually coming up. So remember we did our degrees first, so let's just run through and see if you guys remember how to do the degrees. So this was 0 degrees, 90, 180, 270. The other option for 0, you could have said what? And then what did these angles represent? Okay. And this was 180 minus each of those. So 180 minus 30, 180 minus 45, 180 minus 60, 180 plus each of those. So 180 plus 30, 180 plus 45, 180 plus 60. And here we did 360 minus. So 360 minus 30, 360 minus 45, and 360 minus 60. All right, so could you put degrees on there if I gave you a blank one? Notice it's just increasing as you go around the circle because your angles are getting bigger, so that'll catch it if you accidentally flip a couple. With radians, so 0 degrees, same as 0 radians. 90 degrees, you remember what that was? When pi over 180. So this was 90 over 180 is pi over 2. So it's like 1 pi over 2. 2 pi over 2 is pi. This would be 3 pi over 2. This would be 2 pi if you go all the way around. And then we talked a lot about patterns. With these, everything got a pi. And the denominators matched your reference angles. So everything with a reference angle of 30 degrees had what in the denominator? 30 degrees. If you think 30 times pi over 180 gives us pi over 6. So all the 30s have a denominator of 6. All the 45s had a denominator of 4. 45 over 180 is 1/4. So all those, the denominator is 4. And 30 degrees, or 60 degrees, if you took 60 times pi over 180, you get 1/3. So those all have a denominator of 3. And then the first quadrant, the numerator was just pi. Second quadrant, remember these are like pi minus, so the top was 1 less than the bottom. So 5 over 6, 3 over 4, 2 over 3. Third quadrant, it's like pi plus that, so the top is 1 more, so 7 over 6, 5 over 4, 4 over 3. This you're subtracting from 2 pi, so it's double minus 1. So 6 times 2 is 12, minus 1 is 11. 4 times 2 is 8, minus 1 is 7. 3 times 2 is 6, minus 1 is 5. And so that gave us our radians. Now you could have gotten every one of those the way we did Friday, multiplying by pi over 180 and reducing. But we're trying to talk about some patterns to simplify that. Any questions there? All right. So what I want to do now is kind of a combination of those two problems. We evaluated a bunch of our trig functions. We've talked about the unit circle. When I see sine of pi over 6, pi over 6 is the same as what degree measure? Look at your unit circle. Pi over 6 is what? 30 degrees. Okay, I'm not asking for anything different. It's just a different measure of the angle. Just like I might measure something in, get a measurement of 24 inches, or I could call that 2 feet. Inches and feet are just two different measurements, but they're not actually different, right? So when you see that pi over 6, I'm not asking for anything different. I'm telling you at a certain point, what's the value of sine? So for right now, we are probably going to kind of think, okay, what is that in degrees? Eventually we'll get comfortable enough with radians that we may not have to do that. But when I see pi over 6, I'm thinking, okay, that's like 30 degrees. The sine of 30 is 1/2. Quadrants and reference angles are almost easier when you're in radians, because the reference angle, we know, all we really have to look at is the denominator. This one has a denominator of 4. If the denominator is 4, what's my reference angle? 45 degrees. Okay, the quadrant, we can just look at the pattern. The top is 1 less than the bottom. And which quadrant is the top 1 less than the bottom? Quadrant 2. Okay, quadrant 2. Sine is positive, so cosine is negative. Cosine of 45, radical 2 over 2. Right. Tangent of 5 pi over 3. Quadrant and reference angle. What's the reference angle? 60 degrees. If it's over 3, it's always 60 degrees. Okay, In the first quadrant, the numerator is just pi. In the second quadrant, it's 1 less. Third quadrant, 1 more. Fourth quadrant, double minus 1. So which quadrant is this in? Okay. In quadrant 4, all students take calculus. So cosine's positive, that means tangent is negative. And tangent of 60 is radical 3. These going okay? So it's the exact same thing. The angle I gave you was just in a different unit than we're used to. So, I am really done. You guys have time to work on that homework now. I think I gave you up through 62 on Friday, so you can do the 66 or 86 even, 87, 90, and 90.